Hello everyone, my name is Cao Jingsen, and today I would like to talk about my project, which is Western Medicine Analyzer. The outline of today's presentation is: first, I will talk about the motivation of making this project. The second one is I will talk about the dataset, how I took the data and processed it. The third one is I will talk about the model that I use, which is the YoloV5, and last but not least, the conclusion of the project. So, the motivation of making this project is because there are a lot of Western medicine pills, and I want to classify them so that it's easy to know which medicines is which, and to also list their functionality or usages. Here, on the right side, the image contains a lot of medicines, and for example, if this image is the input, the expected output will be the name of each medicine and also their functionality. So here we have a lot of medicine and we would like to detect them, and so I used an Android app as a tool to accomplish this problem. So here is the simple workflow diagram of the app. First, we are the client and we send the image to the cloud or the internet. Then the server, which also contains to the same internet, receives the image, this image. After that, the server will perform image processing, and then using a pre-trained model that I made, it will predict the medicine and show the result of the prediction. Last, the prediction will be uploaded to the server, and the client will receive the prediction through the internet. And in this case, the prediction is Allegro, which is the medicine here, the image above. Now let's talk about the dataset. The dataset contains 46 classes of Western medicines, and the dataset contains 36,800 images, in which 80% is used for training the image, and the remaining 20% is used for testing the image. So here I only have 100 raw data each class, and I perform 7 data augmentation. So I have an extra of 700 images per class, and the data augmentation that I perform here is flipping the image in x-axis, y-axis, and both axes. And I also perform scaling image with 0.5 times and 0.8 times. I also make the image darker and also add a noise on the image. So in total, there is 1, 2, 3, 4, 5, 6, 7 data augmentation that I do. Originally, I wanted to perform rotating as one of the data augmentation, but the data that I took is a video of the medicine rotating on the device, so I won't need the rotating as a data augmentation. Here is the example of the data augmentation. On the left side is the original image, and the right side is the augmented image. On the very top, we can see that the image is being flipped by x-axis, then flipped by y-axis, and both axes. The second one is I make the image darker, and this one is I added a noise. Last but not least, this one is the original image is scaled by 0.5 times and also 0.8 times. Now let's talk about the model, which is the YoloV5, and the abbreviation for it is you only look once. Here is the YoloV5 model. So in order to use this model, we have to prepare the dataset first, and the data must be well labeled in order to make the most out of the model. The labeling of the image must use YoloV5 or YOLO format. Here is the YOLO format, which you can see on the left image here, and the bounding box will be created like this. So you have to create the bounding box of each image one by one. And the second thing is we select a pre-trained model to start the training, and I use YoloV5 which is the smallest and fastest model available. So the last thing to do is to train the data, and a modulator will be obtained. So here is the result of my training of the model. Here I only use 5 epochs. I only run it for 5 epochs, and as you can see here on the right side, we can see the image and the prediction of the image. Last is the confusion matrix. We can see that almost all of the image get predicted correctly, but some of it still have the wrong result. So After doing this project, I think there can be a lot of things to do in order to make the application better. First, the dataset can be expanded to detect more medicines with different environments. Another thing that we can do is we can also upgrade the app with a feature where user can insert their symptoms and find what medicine is suitable for them. But there's also a lot of problem in making this app, some of which is collecting data and processing them, because it took a lot of time, and also setting up the server, as it is a new area for me to do. So thank you all for listening, and also thank you for Professor Kunchan for the guidance throughout this semester.